this endure as our legacy.
What you are looking at is arguably the most scrutinized building on Earth. And yet, for over 200 years, it has hidden a secret beneath its sandstone and plaster. It has nearly fallen down 5 times. Not from attack, not from war, from something far more insidious. From the very ground it stands on, the wood it was framed with, the stone it was dressed in, and the decisions made and unmade by the engineers tasked with keeping it standing. It's the story of how the White House was saved 5 times from itself. This is the engineering. To understand how the White House was saved, you must first understand exactly how close it came to being lost. Crisis 1, 1814. The British set it ablaze. The sandstone, which Washington personally selected from Aquia Creek, was never designed to withstand fire. It vitrified. It cracked at a molecular level. Engineers would later find, beneath 17 layers of whitewash, stone that was structurally compromised at its core. Crisis 2, 1929. An electrical fault ignited the attic. 3 roof trusses buckled. The original 1817 timber framing, bone dry after a century of use, nearly became a furnace. Crisis 3, 1948. The floors were failing. Not the plaster, not the walls, the actual structural floors, sagging 8.5 inches below their designed position. The building was eating itself from within. Crisis 4, the West Wing. Differential settlement, the ground itself moving at 2 different rates, tore a diagonal shear crack through the limestone skin, running straight toward the foundation. Crisis 5, the East Wing. Water. Constant, relentless water, seeping through the original stone and brick interface, dissolving the mortar that had held the building together for a century and a half. 5 failures, 5 engineering emergencies, each one a near catastrophe, each one solved. By 1948, the structural engineering assessment left no room for debate. The White House could not be repaired. It had to be emptied. Not demolished, emptied. The exterior stone walls, the iconic skin of the building, were to remain standing. Everything else inside would be stripped to the ground and rebuilt from scratch. It was an engineering operation of extraordinary delicacy. You cannot simply gut a 19th century load-bearing masonry shell. Every piece removed changes the load path. Every floor taken out removes lateral bracing, stone fragments, and lime mortar that had turned to powder. The walls of the White House were, at their center, barely more than compacted debris. The new steel frame would have to carry every load from that moment forward. Every building tells its deepest story underground. And what engineers found beneath the White House in 1948 was as alarming as what they had found above. The original 1792 foundations, laid under the supervision of Irish-born architect James Hoban, were brick. Simple, unreinforced brick, sitting on Washington's notoriously unstable Potomac clay. Clay that expands when wet, contracts when dry. Clay that had been moving, slowly and relentlessly, for a century and a half. The excavation went deeper than the original builders had ever gone, down through the 1902 Theodore Roosevelt renovation concrete, down through the original brick footings, down to the gray organic Potomac clay itself, 20 feet below grade. From that base, the new foundation was rebuilt, reinforced concrete spread footings designed to distribute the new steel frame's load across a far wider area, reducing the bearing pressure on the clay to an acceptable level. And where old stone met new steel, chemistry solved what bolts alone could not. Epoxy chemical anchors, injected into the original 1792 sandstone, created a molecular bond between 2 centuries of construction. New steel, old stone, one structure. The foundation of the White House, as it stands today, is not the one George Washington chose. It is the one that saved the building he envisioned.
The engineering challenge of the 1948 White House reconstruction was not simply structural, it was paradoxical. You are asked to build a 21st century structural system, a rigid steel moment frame, reinforced concrete floors, modern mechanical and electrical infrastructure, inside a building that must, when finished, look exactly as it did in 1817. Every steel column must disappear. Every concrete slab must be buried. Every modern duct, pipe, and conduit must be routed through shafts that do not exist in the original plans. Shafts that engineers had to carve from what space remained after the structural frame claimed its necessary volume. And then, only then, could the historic finishes begin. The same 3-coat horsehair lime plaster formula, the same hand-cut millwork profiles, the original doors, pilasters, and ornamental woodwork, carefully removed at the start of the project, stored off-site, cataloged piece by piece, now returned to their exact original positions on entirely new walls. What appears to the eye as continuous history is in engineering reality 2 completely different buildings sharing the same skin. The 1948 reconstruction did not restore the White House. It replaced it, from the inside out, while the world watched the exterior and believed nothing had changed. Of all the structural systems in the White House, the roof is the most exposed to the forces that destroy buildings. Thermal cycling, rain infiltration, wind uplift, and in 1929, fire. The original 1817 timber king post roof trusses were engineering masterpieces of their time. 60 feet of clear span, carrying the full load of the roof and attic floor on just hewn timber and hand-cut joinery. They stood for over a century. Then, the 1929 electrical fire reached 3 of them. The heat was intense enough to permanently deform the wood fibers, a phenomenon called thermal degradation, reducing the load capacity of the burned top cords by an estimated 60%. For 19 years, those trusses carried their loads on 40% of their design strength. Every winter snowstorm was a gamble. When the 1948 reconstruction finally reached the roof, the engineering decision was surgical. Retain and reinforce the undamaged original trusses. Replace the fire-compromised bays with new steel Pratt trusses, lifted through the roof opening by crane, bolted to the original bearing walls with epoxy-anchored steel plates. The result? A hybrid roof system, half 1817, half 1948. Neither visible from the ground, both essential to keeping the building standing.
The West Wing's crisis was not in its walls. It was in its ground. Differential settlement, when 2 sections of a building's foundation move at different rates, is one of the most destructive forces a structure can face. It does not announce itself suddenly. It works slowly, over decades, pulling the building apart from below with a patience that stone and mortar cannot match indefinitely. The crack width monitors confirmed what the engineers suspected. The movement was ongoing, still widening, still working. The investigation bore confirmed the cause. Directly beneath the northwest corner of the West Wing, a lens of soft, high compressibility organic clay, sediment from an ancient Potomac tributary, was consolidating under the building's load at a different rate than the surrounding material. The foundation was effectively rocking, slowly, on uneven ground. The fix 48 mini piles, drilled through the existing foundation and driven 55 feet down into competent bearing strata, bypassed the problem entirely. The building's load was lifted off the failing clay and rerouted through steel and grout to ground that had not moved in 10,000 years. When the hydraulic jacks transferred the load, the crack monitors registered the moment. The movement stopped. For the first time in decades, the West Wing was standing still.
There is a piece of the original White House that no one sees. A fragment of Aquia Creek sandstone, preserved in a controlled environment within the building's fabric. Its surface vitrified by the 1814 fire, glazed to glass by a heat intense enough to melt the mineral bonds in the stone. It was kept deliberately, not as a relic of destruction, but as a forensic record. A reminder that this building, for all its permanence, has always been one engineering failure away from being lost. The 5 crises were not acts of war. They were not natural disasters. They were the consequence of time acting on materials. The slow, patient work of water, gravity, heat, and ground movement on a building designed in 1792 with the best engineering knowledge of its era. What saved it was not any single intervention. It was the willingness, at critical moments across 200 years, to open the walls and look honestly at what was there. To replace what could not be saved, to strengthen what could, to instrument what remained so that the next failure could be found before it became irreversible. The White House stands today on a skeleton built in 1948, on foundations pinned in the 1990s, on a drainage system finished in the 21st century, and on a structural health monitoring network that never sleeps. It is not the building George Washington chose. It is the building that engineering kept alive long enough to matter. And that, in the end, is the whole story.